Welcome back. This is day 2 if you're watching a live stream, or it could be day 276 if you're watching the recorded show for Level Up Azure. IaaS for IT pros. My name is Rick Claus, and we have a guest going to be talking to us in just a moment about some very cool stuff with networking, hybrid connectivity, and other things for day 2. You can kind of think of day 2 as, or this next batch of 4 sessions, as supporting technologies for Azure IaaS that basically are the underlying foundation for how this all works. But in case you missed day 1 or the first 4 sessions, I just want to do a little bit of a recap and let you know that all of those sessions are available online right now from aka.ms/levelupazure. We had Mark Russinovich, the CTO of Azure, come in and kind of give us a roadmap of what's going on with Azure right now, where we're going, and also some important skills that you should be aware of and try to hone up on in order to be more successful in the new world of work, of doing things both on-premises and also up in the cloud with Azure. Then we had the ever hyper-scale, energetic Corey Sanders in talking about the introduction to what is IaaS, some new features that are coming out with the IaaS platform for Microsoft on the Azure platform, and a bunch of other things that only Corey Sanders can really cover in the way that he does. Then we also happen to have Drew McDaniel on for a double hitter, which was absolutely fantastic about the Windows workload, performance tweaks and tunes, best practices, tips and tricks, and even architecture discussions around deep level stuff for how storage and disks are used, how to provision images, and how to architect for the best performance. Some really good stuff in those 2 sessions. So all 4 of those sessions are now available online on channel9.msdn.com, or you can use the short URL of aka.ms/levelupazure in case you're there. All of day 2 sessions, or these next 4 sessions coming up to you live today for this particular live stream, will be available online. I'm not going to hold anyone to an SLA. We happen to get them up there around dinner time in Seattle PST timeframe, but officially our SLA is 24 to 48 hours. So all 4 of them will be up soon after the episode completes for the final one on around 1 p.m. later today. And today we're going to be talking about, as I mentioned, the overall supporting infrastructure that powers the IaaS platform and other things within Azure. And so we're going to be talking about networking. We're going to be talking about hybrid connectivity for your networks, back to your on-premises side of things. A little bit about storage deep dives with pages, tables, blobs, and other fun things. And then doing some disaster recovery and automation. So we got a good lineup of speakers today, all from the engineering teams here at the IaaS world over on Microsoft. And don't forget, if you happen to go to the main page, which is aka.ms/levelupazure, there is a registration button there. And if you haven't registered, make sure you go off and do that, because you'll actually be getting information about a 50% off voucher to go off and take the 533 exam from Microsoft, which is all about Azure and the fundamentals of Azure IaaS for IT professionals. So make sure you register to go off and get that information today. Lastly, we will be taking questions, both in 2 different formats. One format is, if this is a live event, you'll see questions available beneath the player on your browser. You can go in and put in your name and contact details, or just so we know what to call you, and then a free-form text area. And then I'll be able to filter those through to our guest presenters throughout their sessions where it makes sense. We also keep an archive of those, so if we don't get a chance to answer the questions live or after the fact, then we'll basically be using them as some good blog fodder to be able to create some good blog articles, pass them back to the engineers for comments, and maybe post them back up on Twitter. And Twitter is actually the second way that you can interact with us. If you want, go ahead and use the hashtag #LevelUpAzure, and then I'm monitoring that over here to make sure that I can go through and again feed some of those questions in to our different presenters that are going on today. But first off, let's get started with networking and hybrid connectivity. I'm joined this morning, thank you very much for coming in, with Yushun Wang from the networking team with Azure. And why don't you just do a little bit of an introduction about yourself, the team you work on, and some other kind of background information about yourself.
Hi everyone, I'm Yushen Wen. I'm program manager in Azure networking team. So my larger team owns and operates the entire data center network in Azure. And for me specifically, I'm working on the hybrid connectivity side of things. So site-to-site VPN, for example, is one of my areas. And I'm also dabbling in the virtual appliance area, as in the features that on the platform that will support virtual appliances in Azure, and also engaging with the ecosystem regarding bringing their virtual appliances on board to Azure. And before that, I was working in a Windows networking team for Windows 7 and Windows 8. And after Windows 8, then I joined the Azure team.
Okay. Yeah. So we definitely have the right person in the room to be talking about hybrid connectivity and all the goodness that is hybrid connectivity and other things, obviously, with regards to networking here on Azure. So again, if you have any questions about networking, about any of the topics we'll be discussing during this next session for about 50 odd minutes or so, make sure that you go ahead and use the form at the bottom of the page of the player, and also use hashtag #LevelUpAzure, and I'll make sure that we filter them off to Yushen to be able to talk about the stuff. But you know, why don't you give us a bit of background about networking with Azure and that sort of stuff, and let's get this thing kicked off.
Sure. So networking in Azure turned out to be sort of encompassing a lot of features. I mean, fundamentally, this is about how the virtual machine communicate with each other, and also how does the customer control the incoming requests from the internet, and also fundamentally how to let your workload communicate back to your on-premises. And so that's what I'm going to sort of, at a high level, structure my talk today. Basically from the internet, what you can do inside of Azure, and how you connect back to on-premises.
Okay.
So actually, we have a whole load of features that we just released over the last 2 years, and it's very exciting to be working in Azure networking right now. So.
Very, very cool stuff. Now, for this, obviously, demo-wise, it's going to be a little bit of a challenge to go through and to show you some demos. So
unfortunately.
Let's talk about some architecture with the way how this all plans out. I like how you kind of broken this up into 3 major areas.
Yes.
And then make sure that we take some questions as they come up.
Definitely.
I know networking's a hot topic for people.
So what I'm going to do today is I'm going to try to present sort of a comprehensive overview of what Azure networking can do for the customers, for you, and how you can use Azure networking. And, but along the line, I will also try to emphasize a little bit on the new feature that we just released over the last, particularly in TechEd Europe. This is probably a month back. So, I mean, as I'm showing on the screen, we'll be starting out from the internet connectivity, internet-facing features, as in how the customer requests coming from the internet to your Azure workload. And then we talk about how customers like you can structure your workload, how you deploy your workload in Azure, what features are available, allow you to organize your workload in Azure. And finally, how your workload can communicate back on premises. So this is kind of a slide that we like to use, sort of presenting a big picture of what Azure networking is all about. So in the middle, so sort of in the centerpiece of things is the Azure Virtual Network. So as you can tell, most of our features are centralized around the Azure Virtual Network. This is where you organize your workload into front-end, mid-tier, and back-end. And you can actually define the topology based on your address spaces, and you can do a lot of things that just kind of like what you used to do on premises. So the goal here is that allow you to bring your workload to the cloud just like you did on premises. Definitely, there are some minor differences, and we will talk about that. But fundamentally, virtual network is kind of the tools to allow you to structure your workload in Azure. That's kind of the way to think about it. And then from the internet side of things, how the service come into the Azure? How does the customer use sort of a human-friendly name such as .contoso.com to come into Azure? What features we actually have on the platform to allow you to do load balancing, I mean DNS name picking the sort of the workload at the geo area close to you, and providing ACOS and DDoS protection, those kind of things. And also on the back end, how does your workload communicate back on premises? For compliance reasons, a lot of the customers have actually requirement that some of their workload or some of the data has to reside on premises. And this is where the cross-premise connectivity comes in. So we have the secure site-to-site connectivity, and we will be talking about the ExpressRoute dedicated connectivity into Azure as well. So the internet side of things. So Azure DNS is actually a pretty big piece, even though in my opinion, we don't place enough emphasis on Azure DNS. So when you actually create a virtual machine in Azure, I think the demo yesterday, you see that everything in Azure has a cloudapp.net DNS name. That is actually served by our own DNS server. So we provide the entire infrastructure to serve those DNS names. On top of that, we also provide some cool features to allow customers to leverage the DNS name and how they can use it. Traffic Manager is the best example here. So it is basically a DNS name-based load balancing, right? So for example, you see on the screen, we have a www.yourapp.com. And from here, let's say you have kind of a geo-diverse deployment. You have something in the North America, you have something deployed in Europe, you have something deployed in Asia, right? So when a client from the internet actually try to access the DNS name, our system is smart enough to know based on the policy that you select to direct the DNS query to one of these three addresses, for example, right? So let's say if the customer is coming in from the Europe, we actually, based on the data that we collect and based on the sort of the client's IP addresses, we know to direct the query to the European workload. So maybe you have a europenorth.cloudapp.net, then the traffic manager will actually direct the query, returning the address to that particular workload. In this sense, it actually provides sort of a load balancing mechanism, and it can be a performance-based load balancing. It can be a round-robin or weighted round-robin. You can say, oh, I want 80% of my workload on my newer deployment, 20% to the new sort of experimental, or I want to test something in production, those kind of things. And finally, because we have the probing mechanism, right? So anytime you have any workload you need to take down for services, even though it's performance-based, the other side in this example will pick up the workload. So ensure that you always have your backend server available to take the queries. So this is actually very cool.
Now you mentioned a couple of things just in passing there, and I just want to highlight this out.
Sure.
Because I actually completely agree with you. Even with what you just mentioned about how important DNS is and all the stuff that's going on behind the scenes.
Yes.
It's more than just like a form validation that happens when I go in and put in my cloud service name to say ticky box, is that available or not? But is there any kind of administrative interface from the customer to be able to go off and control that side of things, or is it really just behind the scenes and we look after that?
So today, actually, there is. So Traffic Manager, the basic configuration is available in today's the vCurrent portal. So I think Corey taught, and I think yesterday's session we talked about sort of there's a new portal in beta format, and also the vCurrent portal. So if you go to the vCurrent portal, you will be able to see the Traffic Manager icon. So the next slide actually show you the icon. This icon there is actually the Traffic Manager icon you can see on the old portal. And you can do some basic configuration. But most of our new features are available in the API format and also in PowerShell. So definitely the documentation is all available. So you can use PowerShell, you can script, control your deployment, and including Traffic Manager.
Okay, very cool.
And what I'm showing here is actually a new feature we just released back in October. So this is Nested Profile. So Traffic Manager, as it stands today, allow you to do load balancing, either performance-based or round-robin, right? So the nested profile is actually very cool and very simple, just like what I'm showing on the screen. So you have an application.trafficmanager.net. Instead of just going directly to the cloudapp.net or to one of your own private domains, you can actually point to another trafficmanager.net. So imagine you can have two levels of load balancing algorithm or mechanism that have in place, right? So the example I'm showing here is actually, you have the first level performance-based. So it's going to the nearest geographic location of your workload. But under that geographic location, you may have multiple servers serving the same, serving under the same name. You can say, I just want to do round robin within a region. Well, in this particular case, this customer is trying to onboard sort of a new deployment. So you can see I'm using the example to show I'm placing 95% of the requests coming into EU North to my existing EU North.cloudapp.net. But I'm diverting 5% of the live workload into the new deployment. So you can actually control the percentage of the workload that's actually requests that are coming into different workloads. So that's actually very, very powerful.
So basically, you're essentially you're doing like a nested tier option for your Traffic Manager.
Exactly.
Wow. And I never thought I'd do that. Actually, I can think of a couple of customer deployments I should probably go and revisit now. I should go check in with.
Yeah. So after the DNS, right? So the DNS is just kind of the first step, right? Customers say, hey, I have www.contoso.net. So you get an IP address. Now the next step is from the IP addresses, how does that enter into your virtual machine? So until now, we haven't talked anything about the virtual machine, your workload in Azure yet. It's just how you get to Azure. Now, this next part, I'm going to talk about the internet-facing IP addresses for your workload in Azure, right? So I'm showing the VIP. This is the typical, once you create a virtual machine or a cloud service, by default, you get a myvm.cloudapp.net, for example. And the second category of IP address we have is called, actually that might not be a good name, instance level public IP. So internally we call it public IP per instance or something, so that's PIP. So the difference here is that VIP is low balance, right? Even though if you only have one virtual machine in the backend, then it just go to the virtual machine. But if you can actually have multiple virtual machines, multiple web servers, for example, in the backend. And as the example I'm showing, the 151.2.3.4 is a typical VIP. And this VIP is low balance among two virtual machines, VM1 and VM2 I'm showing there. Right? And you can continue to add into the load balance set so that you can have 2, 3, 4, and many, many more. Or you can have one if you really only want to have one workload. Now, one important thing to remember about internet-facing VIP and also Azure networking in general, when customer heard about that, by default, we give you an internet-facing IP address, they actually become nervous. So, I mean, this is my workload. I don't want my workload to accept any incoming traffic from the internet. But this is actually okay because even though we give you a VIP by default, you have complete control of what you want to accept or what you don't want to accept. So by default, if you don't open any what we call input endpoint, actually nothing is coming to the virtual machine. Only when you say, I want to accept TCP port 80 on this VIP to my virtual machine, then we will start diverting traffic to the virtual machine.
And these are just your standard endpoints that you configure on a per machine basis.
Yes, exactly.
So for instance, the default ones for remote management with PowerShell, and also with the altered number that's being used for the desktop connection.
Exactly.
Okay.
So basically, I mean, if you go through the portal workflow, right, you go to the wizard. By default, we suggest you open for Windows virtual machine an RDP port and also the PowerShell management port, right? And for Linux, probably the SSH port.
Right.
But you actually have the option to close off your virtual machine completely.
Good point.
But beware that if you do that, you would have to have another virtual machine you can access, kind of like a jump box fashion. Otherwise, your virtual machine is completely closed up. Of course, you can always go use PowerShell or go to the portal to actually open it back up again.
Just from an architecture perspective, you bring up a good point, is that you really could just have a jump box that you have configured just for the purposes of managing your internal infrastructure. But all the other people have no access to the internet.
Yeah,
that's cool.
But another way to access a completely closed off virtual machine is that if you have cross-premise connectivity, by default, we actually don't block anything within cross-premise connectivity. As in, there's by default no echo from cross-premise connectivity. You can access everything inside the virtual network.
So your hybrid connectivity.
Exactly.
You have from
that's where it comes in. So it's possible to have a completely closed off virtual machine from the internet, but as long as you have a site-to-site VPN or express route connectivity or even point-to-site connectivity, you can still RDP or SSH into your virtual machine.
Okay, good to know.
Yeah. So customer you have complete control of what you want. Now, for instance level public IP, this is actually a different kind of IP addresses. You only get one per virtual machine, and it is dedicated to the virtual machine. So the scenario here is that some application require access to the entire source port range. You don't want to load balance. You might need to accept, and some application does redirect an incoming request to a different port. In this case, we actually open up the port range completely, but we can only go to one virtual machine. So that's kind of the scenario for instance level public IP. And as you can see in this particular picture, for each virtual machine, at most, you can have 2 public IP addresses. One is the typical load balance one from the cloudad.net or in a load balance set. And the instant level public IP is the additional public IP you can associate with a virtual machine.
So this one's kind of like, for layperson terms, kind of like the DMZ, if you will.
Yes.
The DMZ.
We'll talk about DMZ, and we do have features to allow customer to set up DMZ now. Finally.
But just being aware of the fact that you
Yeah.
do have all the ports open, and you do require extra administrative effort
Exactly.
after the fact.
So that is one thing very important. Thank you for bringing this up. Yep. Now, the load balancing algorithm is another question that we got asked very frequent. So by default, the load balancing algorithm is 5-tuple hash base. So statistically, we take the source IP, destination IP, source port, destination port, and the protocol number, and we just do a consistent hashing. And this will spray the workload statistically kind of equal to all the active workload in the backend, right? So this is not load-based, but we basically generally try to spray the incoming requests equally to the backend servers. But we just released a new algorithm that customers can use. It's called source IP-based affinity. This is for the scenario that a client or the customer VM can come in with a request, but it does need to access multiple sort of shared state among multiple connections. One good example is for media streaming type of application, right? So typically you have a flow for media stream, and then you have another flow to coordinate, kind of to stop the media stream. So in that case, both of these requests from the same client must land on the same server. So if you actually configure your load balance endpoint in the source IP-based mode, we will actually direct both of the requests from the same client to the same server. We will make sure that happens. So it's in a sense 2 or 3 tuple based hash. So there's a question regarding how load balancer know which IPs are allowed to route from the internet. So basically, this is sort of an infrastructure level working that we have, right? So we actually advertise those IP on behalf of the customer. Well, that's kind of one way from the customer angle to look at it. But the fact is, those are the Azure IP addresses. So we do own, from the Azure or the Microsoft networking perspective, we own those address blocks. So we advertise those address blocks to the internet. And as I mentioned earlier, you do need to connect those IP addresses with the DNS name, because typically that's how customers use those addresses, right? Oh, there's another question regarding VMs currently support multiple IP addresses. That is actually a feature that we got asked quite often. So it is on the roadmap. So unfortunately, I don't have a confidence schedule I can give out at this point.
I was about to say, we don't cover future-looking things on these sessions.
But I want to answer the question that yes, this is actually a lot of people ask for this feature, and we know about it, and we're working on that.
Yeah.
Let's just leave it at that.
The typical caveat that we always say is that if you're watching this on replay mode, today is December 2nd, and so if you're watching this 6 months down the road, things might have changed, but we'll try our best to make sure that we stay up to date, because things change on a weekly or monthly basis easily in the Azure world.
Right. And there's another question. From the virtual machine to access the internet, does it have to have a PIP? Actually, that is not required, right? So today, when you create a virtual machine in a cloud service, you already have an internet-facing IP address. The instant level public IP is actually additional thing you have to allocate to the particular virtual machine.
Right.
So by default, you already have one, and if you need an additional IP with the entire port range, then you actually add on top of the one that you have.
Okay.
And we are smart enough to know which one goes which.
Okay, so the concept is, if I spin up a brand new machine in a brand new account, nothing configured whatsoever, and I leave the default endpoints up and running, and it's part of a VNet or even just part of a cloud service.
Right.
That machine, once it's initialized, can route and access resources on the internet if it goes off and asks for them.
Yes.
But stuff coming in is blocked except for the endpoints that you've created.
Right. And the nice thing about the block is actually the virtual machine will not even see the packet. I mean, you can imagine it's just kind of getting dropped on the front door because we say, hey, you did not open this door.
It's like it's on the firewall, right? It's like
it is kind of a firewall.
I picture this big,
sense.
Massive consumer firewall. No, I'm joking. This big, massive firewall with blinky lights that we have to worry about.
Right. But I do want to address that particular question. So actually, this is nothing you need to configure from the customer perspective, right? Once you create a virtual machine, the sort of coming in, the DNet, the source net going out, we will handle that automatically. You don't need to configure that. This is slightly different from our competitors' platform.
Okay. It's good to know. Good to know.
Yeah. Okay, so let's move on to the next part. So we talk about how the requests coming in from the internet with DNS name, with the IP addresses. The next part is, what about the workload inside Azure? I mean, this is kind of the key part. I mean, all your business logic, all your server, your SQL, your AD, how do you organize those workload in Azure? Right? So virtual network is the centerpiece of things, because with virtual network, the idea is bring your network into Azure. And on the platform, virtual network is actually our isolation boundary. As in, even the same customer like you, for example, right? If you create two virtual network, they are by default isolated from each other. So you can use the same address. Okay, I'm gonna spin up another one for my testing purposes, and I'll spin up 10 of them if you really want, right? And you can spin them up and tear them down. Just basically depends on how your experiment go. And then finally, you can have the real one that's actually taking the request, communicating back on premises and stuff like that. So the whole idea is bring your own network into Azure. And one feature we just released, and we did not really broadcast about it, is that originally you can only use the private IP address, the RFC 1918, if you're a geeky terms like network geek like me.
Yeah.
Now you can actually bring any public IP address into Azure. So this is actually, I mean, I was surprised about this, but turns out a lot of big companies, especially, I mean, if they go through a couple of mergers, then everybody use 10 as their own internal IP addresses. So some large company actually has a mandate. They say we can only use public IP address, and they go out and acquire a bunch of public IP addresses for their internal use. So for those companies, now you can actually bring the public IP address into Azure. There are a little bit of constraint as usual, right? Yeah. You cannot assign, for example, a multicast or broadcast IP address. This is just common sense. And I know we do reserve, I think one particular IP address is some 168 IP address that we reserve for DNS purposes. But other than those two, and of course, you cannot specify the 169, sort of the dead end, the link local IP addresses. Other than those, you can actually use whatever you want to use in your virtual network. The only thing I want to highlight is that, what I want to emphasize is that even though this is your public IP address, you cannot route to those public IP addresses from the internet, because as far as the internet is concerned, you own those IP addresses. So if a request actually comes into one of those IP address, it'll get routed to your on-premises location, and it depends on how you want to actually forward the traffic to the VM in Azure. So there is a question regarding, we are doing basically net sort of address rewrite, and there's no firewall between VM and the internet. Actually, on the slide, the second bullet point on the slide, exactly what I'm going to talk about.
It's very
ACOS, Network Security Group.
Thank you, Ulrich, for that question.
Yeah, this is a great lead-in. So we just released a feature a month back. We call it Network Security Group. This is basically infrastructure firewall or network ACO, access control list. Actually, let's go to the next slide. This is exactly about this, right? So the idea here is that we want to provide a firewall at the infrastructure level such that you can define the firewall without worrying about what's running inside the virtual machine.
Okay.
Before we have this capability, customer will have to set up their own firewall to allow or block certain address range. But now an administrator can actually set up those ACOs on the infrastructure, and we enforce it before it even comes into the virtual machine. So this is the basic idea. You can imagine you have an access control list. You can specify certain address range. My on-premise range allow, internet range deny. And basically, you set up a filtering condition and then allow or deny. Okay. It's actually very, very powerful. And use this, you can start to do network segmentation. You can define your DMZ, allowing internet requests, but your backend only accept or send to the your own workload or the backend workload in on-premises.
And that's just a recent addition. As of December 2nd, that kind of stuff has been available.
Yes, this is available globally. Yes, I think as of middle of November. So I think we announced the feature with limited availability back in TechEd Europe, which is end of October. Right. And in the middle of November, we completed the global deployment. So now you can have access to this feature globally. The only thing is, like most of our new networking features, this is only available via the REST API or the PowerShell. You can definitely use PowerShell commandlets to add or configure your network security group. And the example, the diagram I'm showing here is actually just exactly the front end, back end setup, right? So from the front end, you can talk to mid-tier you can talk to back end, but neither of the mid-tier or back end can talk to the internet. You can block it. And front end, it is only allowed to talk to mid-tier, but not the back end or not the on-premises. And also we actually have two levels of security group. You can create a security group and then associate the security group with a subnet inside of your virtual network or an individual virtual machine, right? And we kind of do this in a very logical manner. So I'm showing on the slide here. If you're coming in from the network, right? So ingress, you actually hit the subnet first, just like a packet would have traversed the network to the subnet and then to the virtual machine. So you will hit the subnet echoes first. And for each individual virtual machine, if you want to have finer grain control or you want to further lock down, that's most of the case for domain controllers or critical workload, then we actually apply the VM echo before we allow the packet to go into the virtual machine.
Okay.
And going out, because the echo is actually bidirectional, you can do both inbound limiting or inbound allow deny, and also outbound limiting, outbound allow deny, those kind of things, right? So from the virtual machine, you actually hit the virtual machine echo first, just like you would have in the real network. And then you go to the subnet, you hit the subnet echo before it goes out to the internet.
Okay.
So this allows admin to set up sort of a looser, sort of a coarser grain of control on the entire network. And for individual virtual machine, you can actually tailor your control to the individual virtual machine if you need. Yeah.
Now, one thing we haven't covered explicitly at this point in time, but we should probably bring it up,
Yeah.
is the way you configure all these different options.
Yes.
Is it through Portal Now? Is it through Portal Future? Or is it through PowerShell or a combination?
You can definitely do this through PowerShell. And also if you are programming against REST API directly,
REST
for
APIs
sure.
as well.
And it's not available in either the current portal or the new portal yet. But definitely the entire team is working on enabling the new features on the new portal as well. So I don't think this will get enabled on the current portal because we're kind of moving the focus away from the current portal to the new portal. So in the future, this definitely will be available at the new portal.
Okay.
Yeah.
And I do need to ask this one because this has come up an awful lot so far on questions before. Everything that we're talking about right now is all about IPv4.
Yes.
It's not talking about IPv6.
No.
Now we don't need to open up this big can of worms with IPv6, but everything right now is IPv4.
It's IPv4 only. So we do have sort of the age support for IPv6, but the configuration is actually quite cumbersome. So, and I think more documentation will become available to actually educate or to instruct how people can actually handle IPv6 workflow. But right now it's very limited.
Right. So definitely IPv6 is on the roadmap and it's going to be involved. Stay tuned. But at this point in time, think of this all from an IPv4 perspective. How about this one here from FP? When customers move to Azure, the hybrid model, do they typically re-IP the internal IPs, the systems that they're going to be moving to Azure?
So there are two ways to do this, right? So if you actually are moving the entire subnet, because almost all our architecture and organization is based on the subnet, layer 3 subnet. So if you can move the entire subnet and configure your routing, then definitely you can just move those workloads using the existing IP, which have the advantage of not changing your firewall or your policy setting, because those can get very, very cumbersome.
I was about to say that's a nasty project. You have to go off and re-IP an existing solution that's already out there. So
but that said,
you can transport them.
Exactly. But that said, if you really want to just change your IP, use this opportunity to restructure what reallocate your IP address, definitely you can do that.
Okay. Another question there from Amy that came up, which was asking about limiting access to RDP and PowerShell from specific IP addresses using the network security groups.
Oh, yes, definitely.
I'm assuming that she's talking about this from a public coming in perspective.
Yeah.
As opposed to already inside going out.
You can do both, actually. So for the network security group, right, fundamentally think of it as a firewall. Just like a firewall, you say which IP address is allowed to access me on certain port.
Right.
So you can specify for this particular virtual machine, I'm only going to open my RDP port to, let's say, 10.1.1.4. You can lock it down to a single IP address if you choose to.
So that one there is an internal address to the Azure network.
And you can
open it up for.
Yes, and you can also open it up to an external IP address, because as far as we are concerned, we just look at the packet and match the packet to the IP address you configure. So you can define whatever rules you want.
So if you knew what your public IP address was on your provider, then you were able to go in and to further lock it down. So not just anybody.
Yes.
Okay, perfect. Good to know. We'll hang on to the question there, Ed, for just a minute, and come back to a bit more. Just so we
Yeah,
can stay on track.
I need to speed up the pace
Yeah.
a little bit. Now, inside the virtual network, another part of the question is, I think I got asked this question a lot. A lot of the workload has this notion of cluster IP or the floating IP. So we have the matching concept we call internal load balancing. The mechanism we use to do that is actually exactly the same as the external internet-facing VIP that we have. So an incoming VIP, we actually load balance to multiple backend servers, right? So this is using the same mechanism, but only internal facing. So from your front end here, you can say, I want to specify a private IP address for my backend SQL server. And this backend IP address will be load balanced among multiple SQL servers. That's what we call internal load balancing. And there is a difference between this internal load balance IP versus the traditional floating IP. The traditional floating IP actually requires gratuitous ARP. So basically, it rely on a layer 2 ARP mechanism to determine who actually owns that particular IP. For the internal load balancing, we need to replace that with a probing mechanism. So we actually will probe to the backend IP specific TCP port, or you can define an HTTP probe. So to say, okay, just access that particular IP on HTTP port 8081, for example, and based on the response, we will determine whether you are online or offline.
Okay.
So it's equally powerful, but very different mechanism, though. Just want to highlight that particular point. Okay. So the next portion, I'm going to go over very quickly. So another big investment that on the networking side we're doing is actually enable customer to bring network virtual appliances onto Azure. The key thing here is that I'm running certain stuff on premises. Now I want to run exactly the same setup in Azure. And a lot of customers like you actually have investment in terms of the entire auditing or management framework to manage your load balancer, your firewall, and all those kind of things. So we recognize the need, and we're actually doing our part on the platform and also working with the ecosystem to onboard appliances to Azure. And multiple NICs in Azure VM is just a start. So now we release the feature, you can have up to 4 NICs in an Azure virtual machine. And the MAC and IP address will persist. And we are working with ecosystem partners to actually help them onboard their virtual appliances to Azure, right? So in TechEd Europe, we demonstrated appliances from 2 partners. Citrus NetScaler is a very popular appliance, and also the Riverbed WAN optimization Steelhead. So and that they are all leveraging their VM using the multi-NIC features as we speak right now. Now, this is just, and the way we're going to onboard these appliance partners is through the Azure Certified program. So I don't know if you can see from the screen. So once validated, once onboarded, you will be able to just go to the Azure image gallery, select the image, and then just deploy them into your virtual network. So that's kind of our goal here.
And then obviously if they're inside this particular option of the gallery, then there is a licensing agreement that is part of that, using that machine that may either be included or require additional license, just to qualify people when they're talking about licensing.
Yes.
Very cool.
So definitely bring your own license is always an option, but also part of sort of the pay as you go, and also the metered option that will be there as well. Okay, so now let's get to the hybrid connectivity part. So now we talk about internet and we talk about virtual network. Now, how do you connect your workload back to the on-premises part of things? So we definitely have the a lot of you are familiar with the site-to-site VPN connectivity and also the point-to-site connectivity. So the key thing here is that I just want to point out sort of the patterns and the differences, right? So the point-to-site is really targeted for VPN client type of connection. So as in you have individual laptop or even some devices that you want to connect to your Azure workload. And from anywhere, you might be working in a coffee shop, in the airport, or in a conference facilities and stuff like that. Point-to-site is perfect for that because it's tailored to work behind NAT or behind a certain type of proxy. So, but the challenge is that it is definitely not high speed. It's going through sort of 2 levels of tunnels, and it's coming from the internet for small scale. Now the site-to-site is connecting network to network. So this is more of an infrastructure to infrastructure connectivity. This is going through the internet using IPsec site-to-site VPN. And this is typically to connect sort of the stable network for on-premises to your workload in Azure. And then we just released ExpressRoute. This is kind of the newest offering, even though it's already 1 year old, if you can believe that. I want to point out, other than the characteristic that's different, ExpressRoute is actually targeting to have a private connectivity. By private, I mean the connection does not go through the internet.
Yeah.
So it's completely stay within either your own corporate network or the MPLS, the private WAN connectivity that an enterprise may have with a telco provider. And Azure will appear on the MPLS network just like another branch office. So the connection is completely private, not going through the internet. And another big difference is that for ExpressRoute connectivity, you can actually access both your virtual machines in Azure and also Azure offer public services such as storage, Azure AD, SQL Azure, or Azure website, just to name a couple of examples. That is actually not possible with the site-to-site VPN connectivity. For site-to-site VPN connectivity, you can only connect your on-premises to your Azure virtual machine in the virtual network. So that's a big difference between the sort of the two categories of offerings. Now, for the site-to-site VPN connectivity, I think these are familiar point to most people, right? So today you can have multi-site connectivity from your virtual network. You can connect to multiple on-premises location or to another virtual network in Azure. Because if you want cross-region syncing or cross-region communication in Azure, you have to use this VNet to VNet connectivity going through the Azure VPN gateway. And this also works across multiple subscriptions. So typically a company have, for billing purposes, they create different accounts for different departments. When they need to connect to each other, this is kind of the boundary to allow them to actually crossing the account boundary to connect their workloads together. And the next one is the new feature that we released also in TechEd Europe, force tunneling. So I think early on we mentioned when you create a virtual machine in Azure, by default, we give you an IP address.
Correct.
Even though you can lock it down to only allow certain connection to enter, to touch your virtual machine, by default, you can always go out, which may not be a great thing for a lot of enterprise IT, especially for security and auditing consideration. So now we actually have two mechanisms to allow IT to actually control that. One is the first one is you can use network security group to block the outbound access to the internet. You only open specific IP address range, such as the other virtual machines in your virtual network or your on-premises prefixes, and then you can just block out everything else. So this would just black hole the traffic, as in it drop the traffic that's actually going out to the internet. But if you do need to communicate to the internet or to your, let's say your partners or your customers' workload on the internet, but you want to audit and control those access, we released the feature called force tunneling. So this feature allows you to force or redirect the traffic to the internet, actually to one of the tunnel going back to on-premises before it goes out to the internet. But there's one important constraint to note. This one, you can only initiate a connection from your virtual machine. Because imagine if you come from the internet hitting one of the virtual machine that accept internet connection, the return path is actually going to go back out from your on-premises, which actually will have a different IP addresses as the source IP addresses. So when the packet reaches the original requesters, actually it will not be able to recognize. It's talking to one of the Azure VIP, but it's getting a response from a corporate VIP. So this actually will completely lock down. It only allows outbound access from within Azure, but you cannot respond to an incoming internet request from the outside. And we do this on a per subnet basis, right? So the key thing, continuing on the DMZ setup. So we want to allow you the capability to say, this subnet is my DMZ subnet. It can actually accept and respond to internet requests. And I want to limit or I want to force my backend subnet to always go through my on-premise site before it reaches the internet.
So I'm picturing your traditional, thinking of your Visio diagrams.
Yes.
You've got your web servers or your internet-facing responders, if you will.
Yes.
They have a connection to be able to talk to their next level down through your security.
Right.
But then the inside security guys do not have access to go back out that way.
They can only go back either to the front end,
that's
or they have to go
back through the regular
exactly.
channels. Okay,
yeah,
so
that's the idea.
Okay, good.
Now we also have a couple of enhancements to the VPN gateway that we released. So I mean, the key requirement regarding the gateway is always the number of connections that you can have, number of tunnels, and also the bandwidth that our gateway can sustain. So I'm showing a picture, basically the data based on our internal measurement. So we release a new SKU, we call it high performance VPN gateway, that the original VPN gateway can have up to 10 tunnels, and the new one you can have up to 30 side-to-side VPN tunnels, and the bandwidth roughly doubles what you get today, and the sort of the aggregate bandwidth. And the same gateway SKU also apply to ExpressRoute. So we talk about ExpressRoute next. So you can see for the ExpressRoute, actually the bandwidth will be much higher than the side-to-side VPN.
And so this premium high-performance gateway is something that you would have to be, I don't remember seeing it in the current portal.
No,
so
you will have to use PowerShell to create it.
So it's going to be PowerShell to initiate
exactly.
it. And then when it's available in the
definitely.
new portal, it'll be available as a selectable option. Okay.
Yes. And a couple of other new features just kind of on the side that we actually have a no encryption option and also PFS to satisfy some IT corporate requirement. PFS stands for perfect forward secrecy, just making sure that the internet key exchange actually is even more secure than the typical default option.
I would say it's nice to notice that the maximum number of tunnels. I get that question about how many people can I connect up to this, and how many subnets can I connect up to this.
So I do want to mention one point though. So internally, we are constantly going through sort of the stressing because the software is improving, and also the Azure hardware. I think Mark talked about it, and Corey probably also talked about it. We actually phase in and out our hardware generation every 2 to 3 years. So we actually continue evaluate the number of tunnels we can support. And if we feel like we actually are confident to actually set a higher number, we will actually change that.
So you're telling me that the gateway, when you click on the button in the current portal to say make me a gateway to be able to attach up my network, you're basically behind the scenes actually spinning up an instance of an IaaS.
No, actually, it's platform as a service VM, and we actually spin up a pair because it has to be highly available too. So it's active standby.
But in essence, it's a PaaS solution, but it runs on top of the same infrastructure.
The same infrastructure that we are running.
But you don't have to worry about managing any of the lower level stuff.
Yes, it's basically VPN as a service. That's kind of how we phrase it internally.
Okay, so it's using the same infrastructure. Therefore, it takes advantage of all the new hardware upgrades that we're facing in as well.
Definitely.
Okay, now I got it.
Now, the last part, the last but not the least, ExpressRoute. So it turns out customers really want Azure on their network.
Yeah.
Figure that. So this is what the picture looks like today, right? So you have a bunch of data centers, and in order to connect to Azure, you go through the internet using the side-to-side or the point-to-side VPN, right? I mean, definitely it works for a lot of scenarios, but for high bandwidth or when the privacy or regulatory concern become an issue, then you really want to say, hey, can I have Azure on my private network as well? And that is ExpressRoute. So the picture on the right actually shows the sort of the conceptual topology, right? So today you have multiple on-premises location on your part connecting via maybe a telco or an MPLS provider, right? So the idea here is that why can I have my Azure workload popping up just also part of my private connectivity, my WAN connectivity? And that's what ExpressRoute gives you. So the connectivity traverses completely within your private network. It does not go through the internet. And typically for MPLS and for this kind of telco offering, they offer a very good SLA in terms of bandwidth and latency guarantee. So you will have those guarantee all the way to your Azure front door. So that's actually the attractive part. And as I mentioned earlier, the ExpressRoute connectivity allow you to access both your, I think the next slide actually talks about this, your Azure virtual machine in the virtual network, and also the Azure public-facing services such as storage, website, SQL Azure, and we actually have more coming on, so the documentation is getting updated. I mean, you can also do the Azure site recovery and a lot of other services using ExpressRoute.
So again, to step back for just a moment, anytime you have a site-to-site connectivity, or even point-to-site, I guess, and or ExpressRoute, you literally are simply taking a subnet that is connected by the gateway, and attaching it to your internal network. It's fully routable, and there's nothing blocked between them,
unless you want.
Unless you want to block them with the security groups and for other things for the VMs, and therefore the machines can be domain joined. They can have access to internal resources if they're able to route to them. They can have access to your internal resources, can have access to those machines just like they're just an extension of your network, literally. Okay. Good.
And ExpressRoute just kind of make the pipe sort of fatter and
Fatter and more reliable with a guarantee.
well, right? Side to side is also pretty good. But going through the internet does have the challenge that the internet traffic condition is very unpredictable. And ExpressRoute, because this is private connectivity, so it is much more predictable than going through the internet. So that's, but you also pay more. So.
Yep.
Okay. So this is just kind of to highlight the offering that we have. You can go through the option of using the exchange provider. This is for customers that already have footprint. They have their equipment in the colo that they can just kind of literally throw a wire connecting to the Azure front door router. Right. So that's actually very attractive if you already have those kind of setup. And for most enterprises, actually, they typically have a WAN connectivity provider, such as AT&T, Verizon, or any one of those that we listed below, that already the MPLS VPN or other form of VPN connecting their sites together. So we work with these providers to we connect with the providers so that you don't have to worry about how the connection works. So the connection setup is actually very straightforward. So you just go to Azure, you say, hey, I already have AT&T. I want to connect to Azure via AT&T from the Silicon Valley location. Literally, that's all you need to do. And then we will actually give you a piece of identification. It's just kind of a long string of unreadable code. So you take it to your AT&T portal. Literally enter that into the AT&T portal. And between AT&T and Azure, just using that as an example, we will make sure to establish the connectivity, and then AT&T or the telco provider will handle the route propagation for you. And literally after maybe once the handshake is done, within hours, the connection will just pop up. You can already route from any of your on-premises location to Azure, just like that. So you don't need new equipment, and the routing is already taken care of by your MPLS provider. So that's very attractive in that sense. It's almost like seamless.
Now, did you cover as of yet the differences between going with a site-to-site and also ExpressRoute, just from a scale-wise?
Yes.
Because I know that I had one question that came up specifically around site-to-site.
Sure.
And we'll just take a pause just for 1 second. I want to make sure this one gets asked.
Sure.
When you are using the portal,
Yeah.
and you go in and you say gateway connectivity, I've got either dynamic or I've got static choices.
Yes.
The differences between them.
Yeah. So it's actually a different way to configure a VPN gateway. The reason we have both is typically in the VPN industry, there's something called policy-based VPN and route-based VPN. Without going into the detail, the IPsec configuration between the two are different. So to tailor the connectivity to different kind of VPN device, that's why we have our static routing gateway connecting to, let's say, Cisco ASA is a very popular policy-based VPN device. And so is Dell SonicWall and WatchGuard devices, right? And then there's another large category of what we call the route-based VPN device. And that is almost everybody provide route-based VPN device. And that is on our end, we're using basically configuring our VPN differently because of those different type of configuration.
And for people that don't know as of yet, when you choose those options and the gateway is created, also in the portal you have the ability to download the config files that you can then use on these different gateway providers, as well as a PowerShell script that will configure your local Server 2012 or 2012 R2 RAS box that you're using for your own on-site gateway solution.
Definitely. Thanks for bringing this up.
No problem. Good.
Okay, so this is the last slide that I want to show. So for ExpressRoute, definitely, we get asked a lot of questions. Where can the customer come into Azure, right? So definitely our priority is wherever we have a data center, an Azure data center, that's our first choice to have a peering or the entry point for ExpressRoute.
Your best networking connectivity,
exactly,
right? Because
we want low latency. As in, once you reach that point, it's literally within 1 millisecond to get into Azure.
Right.
But we do recognize that Azure data centers are not everywhere. We hope, but that's not the case today. So we do have sort of like an edge location, as you can see. We actually don't have data center in Los Angeles or New York or Seattle, but because there is a large concentration of business in those metro areas. So we actually have edge location to allow customers there to come into the edge location and enter into sort of the nearest Azure data center if they choose to. And also, as you can see, the partner list for the ExpressRoute is actually growing by the month. I mean, this is last month, and I think the list is already changing as of now. So.
Well, it's good to know. That's not exactly everywhere, but it definitely is growing. And,
yes, it is growing.
there. I have another couple of questions around
sure.
security groups. Do you want to answer
Sure.
those ones now? Or?
Yeah, go ahead.
Okay, so Ed, my good friend Ed Horley online was asking about, is it possible to go ahead and to nest security groups anyway?
Great question. So not yet.
Okay.
So today you can specify, but I think one thing you can do is actually that for security group, we have something we call tag. As in, it's not exactly nesting, but you can actually say, I want to allow everything in my virtual network, or I want to allow everything to my on-premises. You can actually use sort of a macro definition to actually cover that. But the only nesting, sort of the nesting-like feature we have is you can have the subnet echo and also the VM echo. That's the only sort of two level of nesting that we have today.
Mm-hmm. I have another question here that came through on the Twitters that was asking about the VPN connectivity that you have, so site to site and point to site.
Yes.
This one is actually asking about, is it possible to use direct access instead? Which is more of a, you probably know the direct access
Yes.
from your previous jobs
Yes.
stuff. I can kind of figure out what the answer is, but I thought I'd let you ask.
No, so today you cannot because so let's put it this way: if you have direct access to your on-premises and
Right.
then express route into Azure or site to site into Azure, it'll just work.
Seamlessly through, right?
But direct access directly into Azure is something that we don't have today.
Correct.
Because you do need to set up the VPN server
Right.
differently than
No
for
problem.
that.
I had another question about the security groups that came up. Again, we're going kind of
Oh, sure.
kind of
Go
mix
for
and
it.
mash because
Yeah.
you had to try to catch up with some of these questions.
Yeah.
One of the questions about the security groups, and I forget specifically who it was asking, is it possible to monitor those security groups so that you can see kind of auditing or changing
Yes.
that goes to them?
So not today, unfortunately, but that is something we're working on. So the feedback that we have gotten since we released the feature is that definitely great to allow customer to block or allow certain echo rules. But then we also want to actually show the log of actually which IP address is getting hit by the rules and stuff like that. So definitely that's something on our roadmap we will release. Yep.
And I know a networking geek asked this one here because it's specifically asking, is ExpressRoute going to be working at layer 3 or layer 7?
It's completely layer 3 at the
Layer
connection level. So layer 7 is something you can do on top of it. But fundamentally, I think all our hybrid connectivity works on layer 3. I think that's the short answer.
Okay, good to know. Maybe time for one more here. Bert's asking about ExpressRoute only available in those providers listed in the previous slide. I don't see any Canadian providers. Does that mean it's not available in Canada? I had to ask that one because I'm Canadian.
So you can replace Canada with any geo that we don't have a provider partner
Correct.
yet. So the short answer is yes, you do need to come through a provider partner that we listed because it's actually a pretty heavy engagement to get the connection established. After we've done that, then the customer experience becomes seamless. But the initial setup is a pretty heavy weight.
It's a really big, massive
But-
piece of router hardware that we have to install.
But we do get a lot of feedback regarding Canada and some other geolocations that we're actively working on. As I mentioned, this partner
Oh,
list
it's-
is actually growing. I mean, we only list the one we signed, the
Correct.
deal that we
And,
announced.
and
so.
just to be clear as well, this is current as of December 2nd, 2014.
You're
In
gonna
case
hold me
watch
to that,
this,
right?
this is just current as of today, and things
Okay.
will change and as they go on.
Right.
Now, thank you very much for joining us for this particular section on networking. We've got the next section coming up in just a moment. We're going to be talking about storage. And I want to say thank you very much for
thank you
coming
for
down
having
and talking
me.
with us.
My pleasure.
Again, if you have any additional questions that are going to be on, you can put them in the comment area inside the video on replay when this goes up on replay on channel9.msdn.com. Or you can keep on talking to us if you want using a hashtag on Twitter, hashtag #LevelUpAzure. And I'll make sure that I pass those questions on to any of the speakers that are going through this particular week. But thank you very much for joining us.
Thank you.
I really
My
appreciate
pleasure.
it. And we'll be back after the very short break to talk about storage on session number 2.